How do we know what dinosaurs ate? Well, we can start by looking at their bones and their bodies. If we find a sharp tooth, this is a replica of a Tarbosaurus tooth with a serrated edge and a pointy end, we can look at carnivores we see in the world today and say, yeah, this is a carnivore's tooth. It was built for slashing flesh, eating meat. If we find something with a more complicated structure that looks like the tooth of something we see alive today that chews hard plants, then we know that this Triceratops tooth came from an animal that ate hard plants. We can look at the bodies of dinosaurs and say, if you're a massive sauropod, you needed to eat a lot of food. And if you had a long neck, it was likely reaching up for something. We can tell the kind of angle that neck sat at. So we look in the fossil record and say, which were the tall trees? What kind of vegetation was it reaching for? It helps us to build up a picture. But essentially, by looking at these bones and these body sizes, we're making educated guesses by relating back to animals that live today. We need a different type of fossil to give us a bit more depth about what these dinosaurs were eating. And luckily we find them. We find trace fossils where the teeth from one dinosaur, perhaps a Tarbosaurus, have made a mark in another dinosaur's bone. And that tells us that this dinosaur with the sharp teeth was actually eating this other type of dinosaur. It gives us that relationship between predator and prey. If we get lucky again, we can find something like this, a fossil poo called a coprolite. Now, if we broke this open, and I don't want to because it's nice and shiny, we'd see inside maybe some bones from small rodents or mammals that the dinosaur was eating, or some plant material that tell us a little bit about its dinner. But it's not always easy to match the poop to the pooper. So we look for other evidence. If we get incredibly lucky, we find the holy grail of this type of fossil, something called an Enterolite, literally the dinosaur's last dinner preserved between its ribs as a fossil. Now, these aren't without controversy. Some scientists will come along and correctly ask, well, could it have just crawled in there after the dinosaur died? Maybe just landed up in the same place? Was it small enough to fit through this dinosaur's mouth? But if we study them closely, we find enough links between the type of animal, the way it was eaten, and the place we found it. It gives us our closest possible clue to dino dinners.